welcome back. Let's talk about these two boring heads. This is the Wohlhaupter UPA1 that I had for years and always served me very, very good. It's very small, auto-facing boring head. It can do not only boring but also facing with automatic outfeed. The problem with this boring head is that it's very small, obviously, and it takes only 8mm tooling at max. And in some cases, even as I do not do very large work usually, an 8mm boring bar is just not cutting it, literally speaking. It's just too flexible, tool deflection is a problem, chatter and whatnot. So I was always looking for either one size up or two sizes up, which would be a UPA2 or UPA3. Again, from Wohlhaupter. But there is also a Japanese company, Kuroda, which built, I think they built the Wohlhaupter boring head in license. If you put this next to a Wohlhaupter boring head, they look very, very similar. I got this for next to nothing off the German equivalent to Craigslist. So I was a bit worried that I might get a box of bricks, but I actually got a boring head. And a very nice boring head that is. Made in Japan. All the best stuff's made in Japan, as we know. This takes 16mm boring bars, I guess. 18mm boring bars. So this is substantial larger and just massive compared to the tiny UPA1. What's cool about the UPA style of boring head, you do not need an Allen key to adjust your diameter. You have a dial up here that reads in 0.01mm per division. That's half a 10,000th of an inch, I guess, which is real nice. And what you dial in here is what you actually get at the cutter. It's no guesswork. Those boring heads are just insanely accurate. All hardened, all ground. Just beautiful pieces. And as far as I can tell, the Japanese license build here is just as well made. It has a T-slot here on the side where you can set a stop, and when you use the auto feed function of this boring head, when the stop runs up against this pin, there is a clutch on the inside and it will stop moving. So you can do snap ring grooves on the milling machine with this guy, or face a diameter to a certain dimension. So I got this, and obviously this is 40 taper, but when I looked at the photos, I was very certain that the shank on this thing is interchangeable. On the Wohlhaupter boring heads you have to be careful. There are some that have an integrated shank, like this one. The UPA1 and 2 all have an integrated shank, and the UPA3 and larger have either an integrated shank or an interchangeable shank. The Wohlhaupter use a weird system with a differential screw and 2 drive dogs that you have to loosen and tighten the differential screw through the shank. But Kuroda did it a little bit different. They just put 6 holes in here on this flange, and they bolt the shank to the boring head, which is brilliant simple. It's very easy, very, very simple, and when you buy it you already see that this is interchangeable. So our mission for today is to clean this boring head up, because it's all crusty as can be. This is grinding dust in here. This in the corner. This is like grease with grinding dust. Not very good condition for a boring head. And get it all cleaned up. Check if somebody put something wrong together, and then make or modify a Morse taper 4 shank so I can use this in my milling machine. Make it as short and compact as possible so we do not create a lot of overhang. But yeah, let's start. Let's take the shank off. I already broke loose the screws off camera to see what I got there. So this is reenacting now. So my surprise reaction when I take off the shank is 100% genuine. Ooh, oh, yes, that's the shank goes off for the taper with the odd style, yeah, you know it, draw bolt for CNC, and it also has a 16mm thread on the inside, so I can use it in a manual mill with a threaded drawbar. And somebody was using a lot of oil. Ugh. And it smells like motor oil. It smells like old motor oil in there. It stinks really bad. We will take this apart. There is no way I'm going to use this with all the abrasive grit here close to the sliding surfaces, and possibly the completely wrong lubrication in this boring head. So let's see how we get this thing apart. Hope I do not get a million springs in my eye when I do this. So I have to figure out how this goes apart. I took off the back plate, which is also the mounting flange. 3 M6 screws. Goes right off. And then we have this ring here, which moves and adjusts the slide down here. I expect there, as you can see, when I turn the upper ring, the inner ring turns. There is a planetary gear set in there, and when I turn the larger ring, you can couple these two rings together with this pin. If you align everything and press down this pin, then you move everything at once. And when you get the pin out, you have super fine in feed. And this is also the automatic facing feed. So this seems to go off as a complete unit. There's a little bit of molybdenum disulfate grease or something like that on here, super dirty. This is a plain bearing in here, looks very good. This up here needs to be cleaned, of course. This is super scuffy. Take this off. Now we have a bit to be careful. We have one gear here. This probably, or for sure, goes down into the body here and drives a warm drive, which engages this warm rack in the slide, moves the slide back and forth. And we have something over here. This is a pin, and this goes along. I can show it. This is a spring-loaded pin which locks one of the rings of the planetary gear set in one of these notches to engage the fine feed. And we have a pin sticking up here because on this boring head, the lock here does not only lock the slide itself via the gib by pressing against the gib, but it also locks the dial and the whole planetary gear set up here, because there is a reason for that. When you turn on the machine, all the inertia in this planetary gear set, especially on a geared machine without a VFD that starts very rapidly, the machine will start to spin, it will jerk, and the planetary gear set here wants to stay where it is at the moment because of its mass and inertia. And that means that when you turn on the machine, it starts to spin, and the dial here stays stationary for a moment. And then it kicks in and moves with the rest of it. So that could alter your set dimension, and also messes up your reading on the dial. So they are locking not only the slide but also the adjuster mechanism with this pin here that moves up and down. You have to be careful not to lose any screw here. Okay, that is easy. You take out the gib screws, pull out the gib to one end. It seems to be hardened. No noticeable wear. Normally on a worn gib you get this wearage of unworn material. This doesn't have it, and this is probably hard as a rock. And then you take the boring head and you slide this over, you lift it a little bit up, so you disengage the worm drive in there, and you just pull it out to one end. Super simple. We have again molybdenum disulfide grease in here, which is probably a very good choice for the rack and pinion for the worm drive here. Here's the worm. Seems to be looks all in very good shape. I'm very happy so far. This needs to be cleaned. I will definitely drop this in the ultrasonic cleaner once I get all the parts out. Okay, I drove out this long pin here, which I figure is the axle for this worm drive in here. And I removed this plate that was screwed on here. And I should be able to get this Oh yeah, we get this whole assembly out in one piece. Kinda one piece. Okay, there's a washer. This is probably to set the end play on the worm. So you have to be careful to keep that, to take a note where to put this when we put this guy back together. Okay, let's get one. There we go. Now the washer is out. This goes on this end. Now everything has a little bit more slop and falls out on its own. Okay, careful. There's a washer on here. And there is a washer on this end of the worm drive. And there is a washer on this end. Ugh, and I probably have to clean my hands now before I get this super sticky grease. Not sure if this... I look like the Tin Man now. Not sure if this is the original lubrication from Kuroda, or if somebody else was already mucking around with this boring head. But we will probably never find out. But that's okay. Yeah, this is the body of this boring head. This is a one piece, all machined from solid. It's hardened. It's ground on all the important surfaces and of course, because it doesn't matter, they also ground all the other surfaces too, as you do when you produce some high quality tooling. I will take some notes where each of the shim go, and fire up the ultrasonic cleaner and clean all these parts before this gets out of hand. Okay, here you can see the planetary gear set taken apart with the ring gear on the inside and the other half on the right side, which is unfortunately in this photo upside down, has the two gears in it. In the next photo you see the inside of this upper ring with the two shafts sticking out, and that's where the two planetary gears go. Unfortunately, again, I already had removed it for this photo. And the small parts on the right side, those belong to the engagement and disengagement mode for the ultrafine and auto feed. Okay, I got all the small parts in the ultrasonic cleaner and they cleaned up beautifully. All the gunk got off completely. Need to sort through them. Some need this for example needs a little bit of stoning for deburring, and apart from that it's all very good shape. All the gears that rotate, this large worm gear here, smaller worm gear, and the small gears out of the planetary gear set, they all have tiny lubrication channels. There's a tiny bore in here that goes to the inside. That's to supply oil to the inside of each of the moving parts. So this thing is designed and built to last, if it's taken care of, obviously. So this is the ultrasonic cleaner I'm using. It's an EMAC ME30. I'm not sure if this model is still available, but something in the same price range. This is about, I think it was around 300 euros, something like 7 or 8 years ago. And I want to mention something. If you set it up with fresh cleaning solution and you're cleaning really dirty parts, or small parts in general that you don't want to lose in the large bath in there, take a glass jar, fill it up with the cleaning solution, drop your parts in there, let them run in the ultrasonic cleaner, and dump away the cleaning solution, the super dirty, messed up cleaning solution. So you do not spend all the cleaning solution in your large container here once at all. This is what I used to get most of the dirt off the parts. This is the cleaner I'm using. This is from Sono Swiss Cleaner T3. This is a very alkalinic or very basic, I'm not sure, cleaner that removes oil and grease and lapping compound and stuff like that. Very good. It doesn't attack aluminium or brass, but it attacks your hands, makes your hands feel soapy, and that's the fat of on your skin dissolving. So that's the reason for the black racing car gloves. This stuff does not protect against rust once it dried off. Robin Renzetti just mentioned on Instagram a cleaner that once dried off leaves a rust protective film. This cleaner does this not. That's the reason why I use I have some rust protective oil in here, very thin oil that leaves a thin film and will protect these parts from rusting until I get this thing back together. And I'm using one of these sorting boxes just to keep the parts in one place when I finally decide to build this, to put this boring head back together. Okay, got all the parts cleaned out of the ultrasonic cleanup, blown off, then sprayed down with the rust protection oil and just wiped down. So I have an oily film on every part that I'm working on now, so I get no rust problems and everything will be fine. To clean up all the ground surfaces, I used these elastic abrasive sticks. This is like a Kratex stick, and this we call them Rust Eraser here. This is just a very, very soft rubber with a lot of abrasive in it. And I would not use it on an assembled piece of a precision piece of equipment because you will get abrasive dust everywhere. But if you have the thing apart, you polish all the surfaces and then you clean it in the ultrasonic cleaner. It's not a problem. I also used Scotch-Brite just to buff it up in overall. Then I dropped it in the ultrasonic, all the abrasive grit got away, I blew it off with compressed air, which got rid of the last bit, and then I just sprayed it down with oil. The boring head went back together exactly the same way as it came apart. No problems, everything had a very precise, very good fit. The only spot where you have to be very careful is with the planetary gear set. The gears are matched and marked where they have to go. They have tiny marks engraved on them and you need to orient them so the marks are in one line to each other. When you take it apart and you look at the gears before you take them out, you will see what I mean. To mount the boring head on my mill, I'm using a spare Morse Type 4 shell mill arbor. I removed the drive keys and then I went on to the tool and cutter grinder and I cut off the end of the shank and I turned a smaller diameter boss. Then I machined the flange that bolts onto this Morse Type 4 shank and has the whole pattern for the boring head. Drilling the bolt circle into the adapter plate. One important thing. The Kuroda has not an even bolt circle. If you look careful at this flange plate, you see that the distance between those two holes is larger than between here and here, here and here, here and here, and here and here. So it's off. I guess on purpose. They have two holes on a center line, and then the four holes, each of them is offset by 55-degree off center line. You have to be careful. So at first I wanted to drill the holes with the bolt circle function of my DRO, but obviously this is not going to work out. So I'm using the rotary table to index the holes. And I'm not even using the worm drive, I'm just indexing with the dial on the table with the worm disengaged. This is plenty precise enough. For this purpose, these are just through holes with clearance, so not a problem. Well, here we are. This is the adapter flange I machined. This bolts to the Morse Type 4 shank that you saw me cut off on the tool and cutter grinder, and the boring head just bolts with 6 screws to this flange. Everything is held together with a large central M12 screw and Loctite. So very rigid, relatively low stick out over the spindle. I'm quite happy how it came out. And the size is not too much off for this machine. It looks massive, as it is massive, but I do not intend to bore out how it's a barrel with this thing. I needed to, when I have a relatively small bore that's relatively deep and long, and I need a stiffer boring bar than an 8mm boring bar that I can hold in my UPA-1 boring head. Then I can use an 18mm boring bar in this larger head here, and I have a very rigid situation. Just to compare, this is the UPA-1 again. That's quite a step up in size. And the operation is the same with the small as with the small one. Here is the lock. This locks the adjuster ring and the slide at the same time.
This ring here moves the slide in and out. But you can also use it as a rapid traverse with the machine running. And we uncouple the gearing up here, and we lock this lower ring in place, and we have super fine feet. When we spin, when we move this up here one time, this down here moves about a fifth of a turn. So it's incredibly fine adjustment. And this is also the auto feed. We let the machine run and we hold this upper ring, and the slide is going to move out at, I think it's 0.07 millimeter per revolution. So it's a facing feed, if you will, like you would face on a lathe. So you see, slide has moved very slowly, and this boring head, you can run this boring head up to around, I think it's rated to 1000 RPM. Which you actually can run them. It's not a problem if you are not running a very massive off-center boring bore. You're not going to bore a 500 millimeter bore at 1000 RPM. Despite burning up the cutter, you will also get quite terrifying out of balance. But you can bore a 20 millimeter bore at the 1000 RPM with no problem. These boring heads really are, I love them. There is also the French D'Andrea boring heads, which are also very nice. They have a hand crank sticking out here, which you can crank to move the slide for a facing cut. I think Tom Lipton showed one of these on his channel once. Take a look at Tom's channel. He might have some footage on that. So yeah, that's the Kuroda UFB3 boring head with a Morse taper 4 shank. Hope you enjoyed this teardown and discussion on this boring head. Thank you all for watching, and see you next time.